Welcome back. Example number 2 from chapter 9. So let's just jump right in. In 1991, the average interest rate charged by the US credit card issuers was 18.8%. Since that time, there has been a proliferation of new credit cards affiliated with retail stores, oil companies, alumni associations, professional sports teams, and so on. A financial officer wishes to study whether the increase in competition in credit card business has reduced interest rates. Very key sentence. Financial officer wishes to study whether the increase in the credit card business has reduced. There is your claim right there. Have interest rates fallen or have they not? To do this, the officer will test a hypothesis about the current mean interest rate. We know exactly what variable we're testing, charged by all US credit card issuers. To perform the hypothesis test, the officer randomly selects 15 credit cards and obtains the following interest rates arranged in increasing order, 14 through 19%. And so we need to test this theory. And so even without the questions written out, specifically asking us exactly what they want us to do, let's go ahead and test this theory. And so step number 1 is always going to be to state the hypothesis. So step 1. State the hypothesis. I think it's pretty easy for us to do this. We know that we're testing the population parameter. And I'm going to go ahead and figure out the sign of the HA first. We know that is going to be have they fallen or have they not fallen? And so this is going to be less than. And if this is less than, we're going to do this as greater than or equal to. But I could have very well just made it as equal to, and it wouldn't matter. And less than or equal to what, or greater than or equal to what? The old status quo was 18.8%. So this is the standard we're going to measure against. So is it less than 18.8 or is it still pretty much 18.8? Step 2. Determine the critical value. So the critical value will be either Z or T. In this particular case, you know it's going to be T because N is equal to 15 and we do not know sigma. And so we're probably going to use T. The other piece of information that you do need, which was not given, was the level of confidence. But you can go ahead and let's do one together right now. Let's do the 5%. In fact, we can do a whole bunch of them together. 1% or even less. So let's just do alpha is equal to 5%. This is a one-tail test. So just for illustrative purposes, I'm going to go ahead and place the distribution I always use here. Just make it a little smaller. And just to kind of show everybody exactly how this works. Here's your center. Here's your 18.8%. Here is your cutoff mark. We don't know what that is yet. Here is your rejection zone. And this is going to be, all of it is going to be alpha is equal to 5%. Again, this is the lower tail test because we are dealing with a less than type of hypothesis. So we know this is going to be a T, and we know that N is equal to 15. So let's go ahead and go to our T table. Here it is. Again, with the way this table works, this is going to be all of 5%, but this is the lower test, or lower end, so this is also going to be 5%. This is a symmetrical table, so whatever you have for the right-hand side, you're going to have for the left-hand side. So not to worry. We're going to take this column right here. This says 5%, Notice that we've got 10, 5, 2.5, 1%, and half of a percent. That's how that works. So we're going to take this column right here, and we're going to choose the right degrees of freedom. N minus 1 is equal to 14 minus 1, 15 minus 1 is equal to 14. So we're going to go to the 14th line. Here's the 14th line. And we're going to do the vertical as well. And so the standard normal number is 1.761. We take that back to our problem. And now we know what the cutoff mark is, and we know that it's going to be negative. Please don't make that mistake because it's on the left-hand side. So negative 1.761. That is the standard against which you're measuring your sample. And so step 3, calculate. Calculate the test statistic. Which I call the t-stat. So the t-stat for us is going to be what? Calculating the t-value. I'm going to call it t-star just to make it different than this t right here. It's going to be equal to x bar minus mu divided by s over the square root of n. I don't know this or this. Essentially, I leave it up to you to calculate, and this is what may happen on the exam. You've got 15 numbers, you would be able to do the calculations here. Now, if you did, you'll see that x bar is going to be equal to 16.8267, and the sample standard deviation is going to be equal to 1.5378. Check my math as usual, just make sure everything works out perfectly. And if you do that, we're going to do that here. So 16.8267 minus 18.8 divided by 1.5378 over the square root of 15, we would obtain a value equal to negative 4.9693, and I'm giving it a few more decimal places than necessary. 2 decimal places should be fine. And so visually you look at this and you see where does it fall on this table right here, on this illustration. So clearly it's going to be here in the green zone. This is the rejection zone. And so if we follow the rules, the decision rules I've talked about before, as to how to reject. I'm going to move this. I'm just going to put that right there. We know that we're going to write it out this way. So step 4, conclude. So since the absolute value of t star is greater than the absolute value of t, reject HO. So the absolute value of negative 4.9693 is greater than the absolute value of negative 1.761. And so we're going to reject HO. If you didn't want to do the absolute values, you could say the following. Since negative 4.9693 is less than, I'm highlighting it here with bolded text, it's less than negative 1.761, reject HO. Okay, because again, it falls in the rejection zone, and therefore it is beyond the critical value. So that is an example of how to do a hypothesis test with t-values.